Hello. Hello. Can everybody hear me?
Yes.
Okay. Okay. So we're going to start. I think Raina's here. So we got 1, 2, 3, 4, 5, 6, 7, 8. Anybody who's like with somebody? No one, no one, no one, no one. Has anybody heard of we don't have 1, 2, 3, 4, 5, 6, 7, 8. Has anybody heard of Brandy and Aliana? Guys?
No.
No. Okay.
No.
Nobody? Okay. So we're going to have like quite a lengthy discussion for today. And please, guys, if you have any questions, just stop me from my explanation so that everybody would be able to understand. Today's a little bit tricky, but you guys should be able to understand it. As long as you guys know what's the difference between left and right, then you'll be okay. Everybody good with that?
Yeah.
Yeah.
Okay. All right. So I think I'm going to start right away. Let me just do a screen cap of our attendance. Oh, okay. Guys, I'll begin by 5:02, okay? Let me
Okay.
just
All right.
share. Okay. Okay, everybody see the blue screen?
Yes.
Yes.
Yes. Okay.
Yeah.
Okay. Blue, happy Easter to everybody.
Okay.
And happy Easter, happy Easter. Okay, guys, let's begin. So I'll just write down our objectives for today. Today's date is April 13th.
Yeah.
Okay, and our objective for today, this is now technically the start of our integral calculus. We're not yet on the antiderivative. We're still on the idea of how to solve areas under a curve. So, guys, our objective for today, we technically have two objectives. First objective for today is introduction to, let me just erase. It's just the introduction to Reiman sum. So, intro to Reiman sum. And then our second objective is left and right side of Riemann's sum. Okay. So as you guys may have remembered, I guess everybody was able to do their homework from last week. We were technically just doing this idea right here. So let me just try to draw our X and Y axis. And let's say we do have a certain irregular polygon. Let's just try to have that. And what we did last week was just to find the area that is bounded by your x-axis and the area or the sides of your irregular polygon. Now, for today, we're going to take it a step further, where we are now going to employ actual f of x functions or actual equations. So let's begin. So we're just going to have like one simple example. If you guys were able to, I think most of you guys were able to take a look at the videos. This is just more of a repetition of the video with a little bit more explanation. So let's say again, we are going to have an x and y axis. This is your x, this is your y, and then let's try to, let me just take a look at my notes. Okay, so let's say we do have a function. Nope, bad. Let's just say let's try to have a curve. Okay, and this curve is being defined by the function of f of x is equal to x squared plus 1. Now, let us say that we're being asked to find the area that is bounded by your x is equal to 1 and then bounded by x is equals to 1 and x is equal to 3. Are you guys still doing okay there? Let me just extend my my function. There you go. So let's say we got this function is being defined by x squared plus 1. And technically, we just wanted to find the area bounded by your x is equals to 1 and x is equal to 3. So we wanted to find this area right here. So that's the use of our Reiman sum. Any questions so far, guys, with the problem?
No.
No. So is it clear that we're just looking for this area bounded by your 1 and your 3?
Mm-hmm.
Yes.
Okay. All right. So let me just erase that shade. Now, in most cases, we've already discussed this, I think, last week, that in integral calculus, what we really wanted to do is we are going to break it down into strips. We are going to break it down into rectangles. And these rectangles will give us more of an approximation of our area. So in this case, guys, we are not yet into limits. This is just more of an approximation. Okay, so we are still in an approximation form. Now, in this case, okay, let's say, okay, we want to divide, okay, we want to divide this area into 4. Let me just, let's say we want to divide it into 4 equal rectangles. Okay, so we are going to divide the area into 4 equal rectangles. Okay, so let me just do a quick approximation here. Okay, so that's, I think this will be a very, very good approximation of our 4 equal rectangles. You guys good?
Yes.
Okay, so we were able to divide it into 4 equal rectangles. And of course, we wanted to find out, since this is 4 equal rectangles, this is defined as delta x. So we want to figure out what's the distance or what's the value of our delta x. So how do we guys do that? So any ideas? What's the length of our delta x, guys? From
It
1
would
to
be 3 minus 1 divided by 4.
that would give us
Your delta x, or 0.5.
that will be, delta x will be equal to 0.5. So just in case for everybody to have an idea, I'm just going to write down our equation. Again, guys, this is only for when you have 4 equal rectangles. Sometimes your problem may give you unequal sides or unequal rectangles. In this case, we are going to have 4 equal rectangles. So how do we do that? Delta x for this one, okay, that's going to give us x sub 2 minus x sub 1 divided by the number of equal rectangles. So in this case, our x sub 2 is 3. Always try to remember that your x sub 2 will always be the biggest value. Okay, so in this case, that's going to be 3. Your x sub 1, guys, what's going to be your x sub 1? Any ideas? Guys, ideas, what's going to be our x sub 1? What's the value of our x sub 1?
1.
Yes, that will give us 1. Why is it 1? Because it's bounded by 3 and 1. Divided by how many rectangles, guys?
3, 4.
4. Very good. So you have 4. Very good. So that will now give us 3 minus 1. That's going to give us 2 divided by 4. And according to Danny, our delta x will just be equal to what, Danny?
0.5.
0.5. 2 divided by 4. That will just give us 0.5. Now, if you may have remembered, we have your left and your right. So what
Mateo needs to be let in again.
Oh, okay. Mateo's gone. Okay. Let me see. Okay. Guys, any Mateo's there already? We're missing a few. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Can we continue?
Yeah.
Okay. So now let us now try to continue. So we have here, okay. So what we want to do now is, let's say we are going to use the, everybody okay? Okay, guys. So we are going to be using the, can everybody hear me correctly? I seem to hear some stutters. All right, okay, so let's try to use the left side. When we try to use the left side, what does that mean? Any ideas, guys? When we talk about left side, and let's talk about the right side. Let's take a look at first, what does the left side and the right side mean? Any ideas?
You'll be using the left side of your points. So that would be 1, 1.5, 2, and then 2.5.
Okay. Does everybody understand the idea, or would you guys need some more further explanation? Why do we have 1, 1.5, 2, and 2.5?
Is this the exact explanation from the con video?
Yeah. I'll just add,
Okay.
like, I think the can is using the left side, and we're also going to be using the right side at this time. And
Yeah. Okay.
Yes.
Okay. That's all I wanted to ask.
Okay.
I thought it was
Okay.
crazy.
Okay. So, guys, let's take a look at first this side of our first rectangle. So we got, this is 1, this is 2, this is 3, this is 4. Let's just try to consider the our first rectangle. So this is our rectangle. Now, when we talk about the left side, what we want to do is we want to consider this side. Would that make sense? We're looking at this side right here. This is your left, this is your right. So we're going to consider the left side of our rectangle. Would that make sense, guys?
Yeah.
Okay, so again, in order for us to get the area, okay, the area underneath the curve, if you guys were able to remember last week, that would just then be equal to the summation of your f of x multiplied by your delta x. What that means is it's just a summation of the area of each of these rectangles. Okay, again, guys, this is again an approximation. The idea, the reason why it's an approximation, because we're leaving away, okay, we're leaving behind this area right here. Again, we're just considering the left side of our rectangle. So again, let's try to figure this one out. Okay, so left side, let's consider this rectangle first. What's the value of our x, guys, if we're considering the left side? Guys?
1.
So you'll have 1 multiplied by, what's the delta x again? This is our uniform problem. So you'll have your delta x will just be equal to what? Guys?
0.5.
So you'll have very good. So you'll have 0.5 plus, okay. So we're done with this rectangle for now. Let's try to consider this rectangle. Okay, what's gonna be the left side value of our x? If this is 1, we add 0.5, what will this be?
2.
1 plus 0.5. What's 1 plus 0.5, Ashley?
1.5.
Very good. So you'll have 1.5. Okay, that would still be 0.5 since it still is a delta x. Okay, you guys following? I think I'll add another one here. So this is now 1.5. If we consider this side of our third rectangle, what would that be? What's 1.5 plus 0.5? Guys, anybody? 1.5 plus 0.5.
That would be 2.
That would be 2. Very good. And then your delta x would still be? Delta x, guys. What's our delta x?
0.5.
0.5. And then we still have another one, since we do have 4. So if we add 0.5 to our 2, that will just give us what? 2.5. Very good. And our delta x will just still be 0.5. So in this case, I'm just going to factor out my delta x. So I'll just have 0.5 multiplied to 1 plus 1.5. Just erase. Can you guys still see, or I think I'm just going to erase the right side.
Shouldn't you have incorporated your function?
Oh, yeah. I forgot. F of x. These are all again, guys, f of x of 1. This is f of x of 1.5. Thank you, Danny. And f of x of 2. So what that means is, since I don't have enough space, can we do it here? Okay. So let's take a look at first. Let me just write it again, guys. Again, I'm factoring out my delta x. Okay. I'll have f of 1 plus f of 1.5 plus f of 2 plus f of 2.5. So what does this mean? So again, your delta x would just be 0.5. And we are now going to solve for our f of 1. Now, guys, remember that f of x is equal to x squared plus 1. So all we need to do is just replace your x with a value of 1. So what is there for f of 1? Ideas?
2.
That would be?
Yes, 2.
2. That will give us 2. So you'll have 2 squared. Or that would just be
No,
2.
just 2.
That would just be 2. Does everybody understand where we get your 2, guys? 1 times, you got 1 square of 1 is 1 plus 1. That would just give us 2. Now for the f of 1.5, how would that lead us to? So again, guys, replace your 1.5 with your x. So we get 1.5 square of 1.5. That would just give us 2.25.
3.75.
3.7.
Did I do it wrong?
Oh, anybody else? Can you check it again?
Yeah, it's 3. I got 3.75.
1.5.
You're talking about 1.5, right?
Yes. 1.5
Yeah, I got
squared
3.
It's 2.25.
plus
1.5?
1. Can you check it again, Wyatt? For me,
So,
I got
1.5 squared is 2.25.
plus
then
1.
Oh, plus
3.25.
all right. Sorry, I did the big dumb. Sorry.
Okay. 3.25. Okay. Ashley, can you do f of 2? Yes. Yes, Mateo?
Can you let Ollie's duck? She needs to get let in.
Okay. Let me check on that.
All
Oh,
of us,
Ali's
People and
here.
Connie Lauren are having troubles with our internet.
Oh my.
Yeah, the internet's really bad tonight.
Oh my. Okay. Oh. Is Ali already there?
Yeah.
I think.
Sorry,
Yeah.
Mr. Moore. My Wi-Fi wasn't working.
That's okay. That's okay. Okay, guys. Is Brandy with you?
Andy's trying to get into.
Okay. So, guys, f of 2?
It's 5.
It's 5. Does everybody understand where we get the 5?
Yeah.
Okay. Okay, let's continue. Oh, here. So let's take a look at plus the function of 2.5. So does anybody have a calculator right there?
7.25.
6.25.
Plus 1 is?
7.25.
7.25.
Very good. So you'll have 7.25. You guys good? So let's try to add this all together. So you'll have 2 plus 3.25 plus
1750.
plus 7.25. It's 1750. Then multiply that by 0.5. What would that give us, guys? Anybody? Yeah? Anybody? You got 1750 for all of this, but you still have 0.5 multiplied by 1750. So what would that give us?
8.75.
Very good. So that
That's
will
what
give
I got.
Very good. So you'll have an 8.75. So again, guys, it's an approximation. So that's
8.75 units squared.
units. Very good. Now, again, we're using your left side. So if you notice, the left side approximation is an under approximation. See that? We were not taking into an account this set of areas right here. Okay, so our next question is therefore, what would therefore happen if we are going to use, okay, what would therefore happen if we're going to use the right side of our squares, or the right side of our rectangles? So
You would be given a higher number.
yeah, therefore we would be given a higher number. So let me just, guys, would you like to do a screen capture of this, because I'm going to erase everything else, including the objectives. Then we're going to do the right side approximation. We're just going to still have 4 equal rectangles, but in this case, we're going to have our right side approximation. Everybody okay?
Yeah.
Okay, so if you want to write it down, if you want to do some notes, I'll begin by 5:26. I'll erase everything by 5:26. Anybody else who still is trying to get in? I think there's... Okay, guys, can I erase now?
Yes.
Yeah.
Okay, so let's try to redraw again our example. Okay, still the same problem. Okay, our function would still be equal to x squared plus 1. Okay, and we're being asked to find the area below the curve and bounded by x is equal to 1 and x is equal to 3. Let me just... Okay, this time, okay, we're still going to have 4 equal rectangles. But in this case, we want to use our right side. Okay, so I'm just going to divide. Delta x would still be the same. That would be 3 minus 1 divided by 4. Delta x would still be equal to 0.5. Okay, and then let us now just try to divide our rectangles into 4 equal sides. Let me just try to do a very, very good approximation here, guys. Now, again, in this case, again, we're doing the right side. So if we try to do the right side, this is what would happen. We are now going to be overestimating. If you've noticed, it goes beyond your curve. So this is again an over approximation. If you notice,
Is there a reason to use like one over the other, like in certain situations, or is it just teaching both ways?
Oh, we're just teaching, just like showing you guys different, two possible ways of doing the left side and the right side. And after this one, we're going to have like a short discussion of what would happen right side will always give us an overestimation, or would it differ on every function that we're going to have?
It would differ.
So I think it would most likely it would differ. So we're going to have some examples on that. So for now, let's try first to do our right side. So again, guys, when we try to do our right side, so in this case, let's try to consider the smaller rectangle that we're going to have. Okay. Again, same equation. It's just a summation of the f of x, okay, multiplied by delta x. So guys, what's gonna be the value for the smallest rectangle? Let's try to call this as rectangle 1. What's gonna be our x for our rectangle number 1? Ideas, guys?
1.5.
That's gonna be 1.5. Does everybody understand why it's 1.5?
It's just going to be 0.5 bigger than all the other numbers that we did, right?
Yes. So
Moved
that's
over
gonna
one
be,
point.
because we're going to be considering this side, that's gonna be 1.5. We just, oh, what happened there? Let me just erase out so that everybody would see. That's gonna be f of 1.5 delta x. Okay, that's for rectangle number 1. Let's take a look at rectangle number 2, guys. What would be the value of our f of x? I mean, what would be the value of our x? Anybody? What's going to be this
2.
side? So we got 1.5. That's going to give us f of 2 delta x plus, okay, this will be our next part. So 2 plus 0.5, that will give us f of
2.5.
2.5. Very good. Delta x plus, we now have this side of our last rectangle. So that would be f of
3.
3. Very good. Delta x. So let us now, again, we're still using the function of x squared plus 1. So 1.5 squared, let me just rewrite this. We're just going to factor out our delta x. What's going to be our 1.5 for 1.5 squared, guys, plus 1?
3.25.
So you'll have 3.25 plus, for the f of 2, that will give us a value of, does everybody understand where we got the 5?
5, yeah.
Okay, plus 2.5 squared. Anybody?
7.25.
Very good, 7.25. And then for our 3, will that give us a 10?
Yes.
All right. So let's try to add them up. Our delta x would still be 0.5. So you'll have 3.25 plus 5 plus 7.25 plus 10. What would that give us, guys? Anybody?
25.5.
Yeah, very good. So you have 25.5, and then we multiply that by 0.5. That will now give us an approximation of
12.75.
12.75 square units. So if you notice, it's an over approximation. The right side in this case is an over approximation. The left side in this case is an under approximation. And then it would also technically show on our values. This is 12.75. The other one that we have is about 8.75, right? questions so far with the introductions, guys?
You take the average of the both, would you get a really close estimate?
Yeah. Without using the limits, that would be a very, very good. Yeah. Again, it's still if we're using 4 equal rectangles. Again, this one would vary if you have, let's say, if you have 5 equal rectangles. The more rectangles that you would do, the better is your approximation. And if you get the average of the two, then again, the better is approximation. Don't worry, we're gonna be using the midpoint hopefully by next week. But in this case, let's just focus on the left and the right. Questions, clarifications? Give you guys like about 1 minute to like maybe examine, do a screen cap if you want to take notes. And then after that, I'll proceed with some examples. Some more examples. Questions, clarifications so far?
No, I'm good. How was your Easter, Mr. Amora?
Okay. So, my Easter, it was okay. Better than my Good Friday though. Because we didn't have water for the Good Friday. So I guess it was a really good Friday. Okay, guys, can I erase?
Yes.
Proceed with the next example. So let's try to erase this. Okay. Let us now try to have now some problems from your let's try to have this one. Then we're also going to have some tables. I'll just try to move this. Okay, I think that will be good. Okay, so this one is an example taken actually from Khan. I would just like, maybe I'll start doing this from now on, since this is a lot more easier for me to write on this part or rather on Khan. So guys, so we have here, again, oh, okay, everybody okay? Somebody fall? Okay, I guess nobody fall.
None of us.
Okay.
Maybe
Okay,
they're
guys.
unresponsive.
Okay, so let's continue. So again, guys, for this one, okay, so again, our function is defined by h of x is equal to x cubed plus 2. Now, it's asking us to find the area between -1 all the way to x is equal to 5. Now, we're going to be using the right Reiman and with 3 equal subdivisions. So this again, guys, this is an example of 3 equal subdivisions. So the formula for our delta x for this one would just be therefore be equal to 5, which is, let me just redo it as x sub 2 minus x sub 1 divided by the total number of equal rectangles. And that would just give us 5 minus -1 divided by how many equal subdivisions, guys? How many equal rectangles?
3.
So we're going to have 3. So therefore, delta x, 5 minus -1 will just give us
6.
6 divided by 3 will just give us a
2.
delta x of 2. Very good. So we now have a delta x of 2. So we are now going to divide this into 3 equal subdivisions. So this is going to be rectangle 1. This is now, oh, my bad. Rectangle 1, rectangle 2, and then rectangle 3. Now, if you've noticed, guys, what do you think? Is this going to be an over approximation or an under approximation since we're using the right Reiman? Is it over?
Over.
Very good. So we're going to be using this. So it's an over approximation. And then also for this one right here. So if you've noticed, it's actually an over approximation. There we go. Okay. Again, we're using this side of our rectangles. Okay, guys. So again, area is just technically equal to the summation of your f of x multiplied to our delta x. So let's take a look at first area or rectangle number 1. Okay. So guys, from -1 to 1, what's going to be the value of our x for this one? F of
1.
1.
Very good. F of 1 multiplied to delta x plus, let's take a look at rectangle number 2. That's going to be f of what?
3.
3.
Very good. So f of 3 delta x plus, the last one will be
5.
f of 5. So you'll have f of 5 delta x. So let's factor out our delta x. Okay. So guys, that's x cubed plus 2. So what's going to be your f of 1, the value of your, h of x, my bad. Just for using h of x. So that's going to give us
3.
2. 2? 2 or 1 plus
3.
2. So that's going to give us a 3. So that's going to give us a 3. Okay. Plus, okay. What's going to be
9.
4? That's going to be 9 or 29?
29.
29 plus, how about for f of 5?
127.
127. Okay. Your delta x again is just going to be 2 multiplied to 3 plus 29 plus 127. Will that give us 3 plus 29?
159.
127 is 159. Does everybody have the same values, guys?
Yeah.
And then we multiply that by 2.
318.
So your final answer would just give us 318 square units. Easy? Questions, clarifications? So I guess I give you 1 minute to do a screen capture and then I'll proceed with the next example. Let's try to have unequal subdivisions. Everybody good? Can I erase or not yet?
Yeah.
Okay. So guys, let's do another one. Let me see, we've done that. I want to do That's still subdivision. Subdivision. Okay, so I think we might have to do. Let's try to do this one. So in some cases, this problem, it doesn't give us a graph. However, it does give us a table. Okay, now let's try first to examine the problem. Okay, notice that we're just given a table. Okay, and one more thing is it's from -1 to 5. Okay, our next step is we are now going to take a look at this statement right here. Okay, it tells us that we do have 3 unequal subdivisions. So what that means is, let's say we don't know what the graph is, what the graph looks like, but let's say we do have just like a graph like this, but we're being told that our, let's say our values from -1 to 5, okay, are being subdivided into 3 unequal subdivisions. So what that means is our rectangles, we're using the right side, okay, we might have this, and we might have this. What that means is your rectangles are not equal. It's very, very different from what we had earlier, where all rectangles are equal. In this case, we do have different widths of our rectangle. So how would we be able to compensate with this one right here? Now again, the general formula would still be the same. We would still have the summation of our g sub x delta x. Now, in this case, okay, our delta x would vary from every rectangle. You guys good? Okay, now guys, if you notice, we could create a rectangle here. This is going to be one rectangle from -1 to 0, another rectangle from 0 to 3, and another rectangle from 5 to 3. And we're using the right Reiman sum. So let's take a look at first rectangle number 1. Okay. Let's take a look at first rectangle number 1.
Wouldn't it just be 0 minus -1 over 1?
0 minus 1.
0 minus -1 over 1.
Over 1, or yeah, or that would just be the delta x. What's going to be the delta x? That should just be 0 minus -1. So you have 0 minus -1. That's again, guys, that's just going to be for your delta x. Okay, now let me just erase this because we still have to find out. Okay, that's going to be your delta x. But if you take a look at between 0 and -1, what would be there for the right side of our rectangle? Is it going to be 0 or is it going to be -1?
0.
0. If that is there for 0, then we would just say g sub x would just be g sub 0. And for our delta x, we are now going to have, again, guys, that would still be x sub 2 minus x sub 1. In this case, that's going to be 0 minus -1. And that would just give us what?
1.
1. Very good. So you'll have g of 0 multiplied to 1. If x is equal to 0, what's going to be your g sub x? If x is equal to 0, what's going to be your x? I mean g sub x.
6.
So you'll have 6 multiplied to 1. That's the area of our rectangle number 1. So that will just be 6. Now, let's take a look at rectangle number 2. Okay, guys? So for rectangle number 2, okay, this is your left side, this is your right side. So what's going to be our g sub x for this one? G of?
3.
Very good.
3.
3. Very good. And then our delta x. What's going to be your delta x, guys? 3 minus. Take a look at. It's not, again, it's not going to be
3.
always be 1. This will be 3. Why is that 3? Because we're looking at
3 minus 0.
3 minus 0. Very good. So if g sub 3, if x is equals to 3, your g sub x will just be equal to a value of 1, right? Multiplied to 3. So 1 times 3, that would just give us 3. By the way, these are all square units. Square units. Then rectangle 3, guys. That's going to be g of, your right side is going to be g of 5 multiplied to, what do you think is our delta x for this one? What's 5 minus 3?
2.
That will
2.
just give us 2. Very good. So when x is equals to 5, g sub x will just be equal to 8 multiplied to 2. Everybody good in that? So that will just give us a
Yes.
total of 16 square units. So guys, that's 6 plus 3 plus 16. What would that give us?
25.
25.
Very good. So that will just give us an answer of 25 square units. Questions, clarifications? That's like already example number 3 so far.
Yeah.
Okay, guys, one more, and then let's call it a day. Would
Sounds
you
good.
like? Okay. Any more questions, clarifications? Is it so far easy? I think it's easy. Can I proceed?
Yeah.
Okay. So I'll be deleting this. And I'll add one more. Add image. Oops, cancel. Add image. Let's do, we're done with that. Let's do this. Were we able to do this? No, I think we're not able to do this. This one is an example of a left Reiman sum. Okay, so this one, okay, this one is we're using the left Reiman sum. This is our function, h of x is equals to 1 over 7 minus x. And we are being able to do 3 equal subdivisions. So again, guys, this is 3 equal subdivisions. So we could do our basic delta x, which is just equal to x sub 2 minus x sub 1 divided by the total number of equal rectangles, or in this case, subdivisions. So our x sub 2 is the largest value of our x. That would just be 5 minus x sub 1 is 2. How many equal subdivisions?
3.
So that will just give us 3. So 5 minus 2, that will just be 3 divided by 3. So delta x will just be equal to a value of 1. Okay, case good. So let us now try to proceed with dividing this into 3 equal parts. So I guess, yeah, most likely this is what we're going to have. And then since we're looking for our left side, is this going to be, will this be an over approximation or an under approximation?
Under.
This is going to be an under approximation. Why is it under? Because we're being left behind with these areas right here. Okay, so let's continue. Again, area, total area is just equal to the summation of f of x delta x. So in this case, we have the left side. Let's take a look at area rectangle number 1. What's gonna be our x for this one, guys? Anybody? It's the left side. So what do you think is gonna be our x? Take a look at this rectangle right here.
2.
We're looking at the left side, so that's gonna be 2 delta x plus, okay, our second area, second rectangle, what's gonna be our f of, or what's gonna be the value of our x, guys? Anybody?
3.
Very good, so you'll have 3, okay? Your delta x will still be delta x. And then for your third rectangle, what's gonna be the value of your x?
4.
So that will give us a 4 delta x. So let's factor out our delta x, and then let's already replace our delta x with a value of 1. So you will now have 1 multiplied 2. So guys, f of 2. So let's take a look at this right here. So at f of 2, h of 2. Why do I always write h of 2? So h of 2, f of 2 will just be equal to 1
over 5.
7 minus 2. That will just give us 1 over 5. So you'll have 1 over 5 for the f of, h of, why do I always use f? For the h of 3, this one will just give us 1 over 7 minus 3. And this will just give us, guys?
1 over 4.
Very good. 1 over 4. So that's plus 1 over 4 plus, okay, h of 4. This one should be all h. That will just be 1 over 7 minus 4. And that will just give us 1 over, guys, 3.
3.
So therefore, we now have 1 over 3. So anybody there with a really,
Your
really good,
LCD is 60.
and that's gonna give us,
47 over 60, I believe.
that's gonna give us a total of 47 over 60. Yeah, I think it's 47 over 60. 47 over 60 square units. Questions, clarifications? Is it hard?
No.
Nah, I think it's okay. So guys, questions, guys, clarifications. I think for next week, let's try to do midpoint. And hopefully by that, we could definitely go to the anti-derivatives already after that. So can we, any more questions, clarifications? What happened to Brandy?
I don't know. I don't think her Wi-Fi is working.
Oh,
She
okay.
hasn't texted me back.
Oh, okay. Okay. So guys, any questions, clarifications? Were we able to do our objectives for today?
Yeah.
Okay,
Yes.
so shall we end our meeting and then hopefully see you next week? And then I'll give you
Okay.
something to read and then hopefully, again guys, assignments, homework, you have it already on Can. So goodbye, goodbye, goodbye.
Bye, Mr. Moore.
Okay.
Bye guys.
Mr. Moore.
Bye. Bye,
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 friends.
bye. Bye. Happy Easter. Love you too. Bye
I love you
guys.
too.
Happiness.
Bye. Be safe.
Bye.
Bye bye. Bye bye. Bye.